my clock, so I'm going to start the recording and go ahead and start sharing content. Let's see, I'm going to need to share PyCharm. I'm going to need to share Google Chrome. And we'll get to the terminal if we need it. So let's get to the slides. Okay, so operators and conditionals is today's topic, and I will try to tie it to homework 1. That is the administrative note. I put a note on the class Blackboard that homework 1 is out. It is worth 50 points, which is typical for the 6 homeworks this semester. You will see instructions everywhere that say it's due Friday. That is for the majors class, of course. For us, homework 1 is due next Monday, the 15th, if I'm looking at my calendar correctly, at midnight, 11:59 p.m. next Monday night. So ignore everybody else who says it's due Friday. For every other section, it's due Friday. For our section, section 40, it is due next Monday. Now, the word I would give you is please try to jump on this and get it done early, because homework 2 is coming out this Friday. It'll be due the 22nd. Things are going to start to pile up on you. So try. I understand you've got conflicts. You're full-time students. A number of you also have full-time jobs. You're on sports teams. And of course, we're in the middle of a pandemic. I understand you're busy, but please try to go ahead and jump on this. Get it started. Don't wait until the last minutes. Now, I want to talk about submission, submitting your homework. Submission instructions are in the assignment. They are on GL. It's submitted on GL. Please submit early. Now, you can submit multiple times. So this is the old joke about voting, vote early, vote often. Submit early, submit often. If you submit multiple times, only the final submission is going to be graded. The new submission will overwrite the previous one. Why this is important is we try to be fairly lenient on the partial credit, but we are not at all lenient on the late. Okay, every semester there's always half a dozen people or more out of this. Well, I guess this semester there's 300. Typical semesters is closer to 500 or 600. There's always a few students who wait until the very last minute and don't want to submit for the first time until it's perfect. And so you're sitting there at 11:59 p.m. on the due date. You've got it perfect. Every last comment is nailed down. Every print string is perfect. This is the best homework we've ever seen. And your internet connection fails. And by the time your internet connection comes back up, it's 12:03 a.m. and we program GL to automatically shut off, excepting at midnight, so you can't submit, and so now we have to figure out what's going on. Please don't do that. Please don't do that person. Go ahead and submit early. I mean, if you are working on it next Monday night, that's fine. Submit it at, say, 9 or 10 o'clock. If you submit at 9 or 10 o'clock and it's 90% there, you're going to get your 45 out of 50. You'll be in good shape, as opposed to your internet connection fails at 11:59 and then you don't submit everything and then you got a 0. And so, we just don't want to go there. So go ahead and make sure you submit early. If you're working on it next Monday night, the last night it's due, submit it a few hours before the due date. You've got something in. We're also a lot more sympathetic in that case when you've got it almost complete and you're just tweaking the last thing to get those last 2 points and you couldn't quite get that in time. We're pretty sympathetic about fixing those last 2 points as opposed to, again, not doing it. So just as a reminder, we will at the end of today's lecture, presuming there's time, talk about the homework in more detail. But please, please, please submit it on GL early. You can submit multiple times. Only the last one's graded. You're good. All righty. That being said, let's talk about operators. Now, the definition of operator is kind of circular, okay? Sorry, I'm trying to kill Discord. I've got Discord set up to ping me when there's a new message posted, and so I'm getting these constant beeps in my earphones. I hope they're not going out over the audio. If they are, that'll stop. Back to topic. Circular definition, an operator is a special symbol that carries out some operation. Well, okay, operators carry out operations. All right, fine. But the point is they're used to do things. Ignore the word operations. They're used to do things to variables or values. Okay. Now, there's a whole bunch of different types of operators that you'll go through as you learn Python, as you get through this. But the 4 types we're going to focus on for like the first half of this class that we're going to introduce tonight are arithmetic, comparison, assignment, and logical operators. Okay. And arithmetic operators are just almost exactly what you'd expect. They perform arithmetic on ints and floats. Some of them have weird syntax on strings that we'll get to next week. For now, arithmetic operators operate on ints and floats, so they do things you'd expect. And we're going to work through some examples. All right, apologize for that sneeze. Couldn't mute in time. Comparison operators are also the standard things you've learned from arithmetic all these times. Equals, not equals, greater than or equal, greater than, less than or equal or less than. They're used to compare values. Sorry about that. Allergies are bothering me. Assignment operators, we talked about the equals sign being the assignment operator. It loads a value into a particular variable. There are some other things that are used for shortcuts because computer scientists tend to be lazy. Guilty as charged. And we've come up with shortcuts over the years, so you don't have to type quite as many keystrokes and work at all of those. And then there are 3 logical operators that are used to derive Boolean values, and they are and, or, and not. So these are the ones we're going to talk about in detail. Now, let me go to PyCharm, and let's talk about arithmetic operators. Okay. Why am I not typing in my space? Hold on a second. Okay, here we go. Arithmetic operators. Most of these are fairly simple. Print 5 plus 9.0. It would help if I typed the plus, not the equal. Okay, let's run that. Let's run February 8th coding. And we can see that that's 5 plus 9.0 is 14.0. Plus is just addition. You know how it works. And in terms of types, if you add 2 ints, you get an int. If you add an int and a float, if you add 2 floats, you get a float. Just like you've always done with real numbers and integers. If you add 2 integers, you get an integer. If you add 2 floating point numbers, you get a floating point number, and so on. Subtraction is the same way, and rather than run this, I'm just going to go to Python console and type them in directly. Okay, 9 minus 5, that's the integer 4. 9 minus 5.0 is the real value, 4.0. I mean, subtraction is subtraction, right? You've known this. Multiplication is the star or asterisk. 5 times 6 is 30. 5 times 6.0 is 30.0. It works the same way. And then division is the slash. 30 divided by 6.0 is 5.0. 30 divided by 0.6 is 50, and so on. Now, the single slash, and when I say slash, I mean upper right to bottom left. Okay, upper right, bottom left, that's a slash or a forward slash. A backslash is the other way, the upper left to bottom right. A slash, a single slash, is called real division. So let me make a note about that so we don't lose it. Or floating point division is a single slash. So y equals 9 divided by 5. That's a single slash. Now, there is another thing you can do called integer division. And if you've taken a math class where you've done modular arithmetic, you've seen this. Okay, think back to your early days when you learned how to divide in elementary school, whatever grade you were in. And you could say that 9 divided by 5 equals 1.8. Or you could say that 9 divided by 5 equals 1 with a remainder of 4. This is the double slash or integer division in Python and the modulus or percent sign. So let's give an example of that. If we say 30 / 5, that is integer division, just take 6. Well, that was a whole number. That one worked out the same. Let's take 30 / 7. 30 divided by 7 is an integer, 4, because 7 goes into 4. That 7 goes into 30 4 times with remainder 2. Integer division truncates. It does not round. It always truncates. And so the result you have is that 30 integer divides 7 is 4. 30 / 7 floating point division gives you 4.28 and so on. And as I mentioned, the default is always I believe, 16 places of decimals. Apologies again, the allergies are acting up. No, I do not have COVID. It doesn't matter, you're away from me anyway, but at any rate, it's just allergies. Okay, 30 divided by 7 is floating point division. You get this fraction. 30 / 7 integer division is 4. But what about that remainder of 2? That's where the percent comes in. 30% 2 says, sorry about that, 30% 7. This says take the integer division, throw away the quotient, and give me the remainder. This says throw away the remainder and give me the quotient. This says throw away the quotient and give me the remainder. So when I do both of these, I get 30 integer divides 7 is 4, and 30 modulus 7, or the remainder, is 2. Okay, that remainder is called the modulus, and so this is called modular arithmetic or modulo. So y equals 30% sign 2. Let's make 7 because 2 is 0. This is 30 modulo 7, or 30 mod 7, and it's just, remember, going to take the remainder. So those are the two new things. Everything else you've seen arithmetically in Python is exactly what you expect: plus, minus, times, divide. Integer division and modulus are kind of new, although you should have seen them in your math classes. The other thing is exponentiation, and exponentiation is just a double star. Y equals 5 star star 3 that's 5 cubed. And 5 cubed, as we know, is 125. So double star is exponentiation. That's take 5 and raise it to the power of 3. Now, interestingly, if you say 5 to the power of minus 3, that says take the cube root of, that says 1 over 5 cubed, 1 over 125, and 1 over 125 is 0.008. So exponentiation works the way you expect. The only thing is to get used to the terminology, and the terminology is the double star. So that's what this table does on this slide, is it summarizes what these operators are and what they mean. Plus, minus, times, and the single slash, floating point division, nothing surprises you. Double slash, integer division, take the quotient. Percent, modular division, take the remainder, and then double star is exponentiation. Those are the arithmetic operators you need to know. Comparison operators, again, these are the things that you've seen, and the only thing significant here is the terminology. Let's go back to pie chart. Remember, we said y equals 5 is an assignment. It loads the value of 5 into y. We asked the console to show us, and y equals 5. Double equals is a comparison. This is asking, is y equal to 5? Okay, and in this case, we're going to get the Boolean value true, because y is indeed 5. So this is a very common mistake, and it doesn't matter how long you've been programming. It happens a lot. Assignment, single equals, y equals 5. Comparison is double equals, no spaces between those two equals. That's crucial. If you put spaces between those, then you'll get an error. Okay, so furthermore, if we go y equals 5, that's fine. Now we ask y equals 4, that's false, because y is 5, it's not 4. Okay, so you understand how to compare for equality. The only issue is syntax. It's a double equals. Not equals is the same thing. It's just a matter of syntax. And here, it's a exclamation point equals, sometimes called bang equals. The exclamation point is sometimes called the bang. And so you'll see bang equals or exclamation point equals. That means not equals. Okay, and so the syntax here is y not equal to 4. And that's going to have with value true, because y is not equal to 4. Okay. So the rest of the comparison operators are exactly what you'd expect, right? Greater than or equal to, less than or equal to. And you're doing comparison operators mostly on ins and floats. You can do comparison operators on strings. You can check if one string equals another or not equal to another, and we'll do that very quickly. Fix that one. So let's say we had the assignment of S equals the string Brady won again. Not that I'm happy about that, but he did. Now I'm going to say S not equal to Mahomes repeated. If you're not a football fan, don't worry about it. If you're a football fan, you'll understand what this means. Okay, so first we'll copy this in. And now this is an expression. It's not a full Python statement. It's an expression that is going to give me a Boolean value of true. Why is this true? Because S is not equal to Mahomes repeated. If I said S equals Mahomes repeated, that's a Boolean value of false. If I messed up and typed single equals, nothing happened because that just assigned the value to S and changed my value. Okay, so you can compare strings. They must match exactly. Okay, so let's go back and set S equals Brady 1 again. Now, let's change the capitalization. It's the same darn thing. I've got one letter that is different. I'm checking to see if this is equal. Okay, I'm sorry. Bang equals is not equal. Okay, got it. Okay, great. Glad people are jumping in the chat to ask questions and answer them. That's great. Okay, so here, notice that these two strings look pretty identical. The only difference is here I had a lowercase, here I had an uppercase. This is case sensitive. That is not the same string. That's why it's false. It would be the same thing if just there was a spacing problem. Now I've got a capital B, but I'm missing a blank space. Same thing. Okay, so you can compare strings. Equals equals. Comparison of a string is an exact match. Only if they are exactly the same string. Assignment operators. We talked about equals. Python lets you take some shortcuts. Okay. You will find that you type a lot. Things like this. When you're writing code. Y equals 5. Do something, a bunch of extra code. Y equals Y plus 1. This happens a lot. Well, I'm proud to be a lazy computer scientist. You can replace that with Y plus equals 1. Okay? So let's just say Y equals 5. Y plus equals 1. And now the value of Y is 6. This is just, the phrase is syntactic sugar. Syntactic sugar means it's kind of a neat thing we invented to print to make it a little easier. After all, Y plus equals 1 is not counting blank spaces. Well, counting blank spaces, it's 1, 2, 3, 4, 5, 6 keystrokes. Up here, Y equals Y plus 1 with blank spaces is 1, 2, 3, 4, 5, 6, 7, 8, 9. So I type 6 keystrokes instead of 9. That's a 50% savings, 33% savings, depending on how you want to measure it. I win. I save 3 keystrokes. So we have Y plus equals 1 means Y equals Y plus 1. We have Y minus equals 3. Now, this is going to be important. This is the same as Y equals Y minus 3. It is not Y equals 3 minus Y. Okay? So here we know that Y equals 6. So Y minus equals 3. Now Y is equal to 3. That's because it's y equals y minus 3, not y equals 3 minus y. So addition and multiplication, of course, as we know from arithmetic, are commutative. It doesn't matter which way you do the operators. Y plus 3 is the same as 3 plus y, but minus and divide, it's not the same thing. So it's important to understand the order. Not a big thing, you just have to get used to it. Y times equals 3. Again, it doesn't matter what order, but if you do this, y times equals 3 says y equals y times 3, which is now 9. Now, we can only do this for floating point division. You cannot do this for integer division. Y divided equal 3. This is going to be, where's my comment? There we go. Y equals y divided by 3, not y equals 3 divided by y. Okay? Y divided equal 3. And now we see that y is 3.0. Again, 9 was an integer, 3 was an integer, but this is floating point division, and so it always produces a float. Okay, when you use this division, it produces a float. Now, y slash integer divide 3, that's interesting. Okay, I'm going to have to look into that because that is supposed to be an error. Now, this is the professional version of PyCharm, and there's some interesting issues as I've been playing with it. Okay, that is actually in the language specification. The integer divide is supposed to be an error, especially when you're dealing with a floating point number. So live demos, aren't they great? Learn floating point divide. Do not worry about integer divide at this point. I'll figure out why PyCharm is doing that. Okay, but getting back to the slides, equals and then 4 other things that are shortcuts that let you type fewer keystrokes. Plus equals, minus equals, times equals, and divided equals. Now, Python does not have, real quick, back to PyCharm, y plus plus. Other languages, this is the same as y equals y plus 1. You add 1 so many times, and over the next 2-3 weeks as we get into loops, you'll see this. You add 1 so many times that a number of other languages have y plus plus equals 1 or y equals y plus 1, whatever. Python does not support that. And so as you can see, when I've typed y plus plus, rather than telling me y is y plus 1, it basically does nothing. It tells me I've got an error, but I haven't got a full command, so it doesn't know what error I've got yet. So it's waiting for me to type the rest of the command to get out of this mess. So that was the point there. If you haven't seen another language with the C++, the Y++, whatever, that's fine. Just if you have seen it, you're expecting Python to have it, it does not. Okay, so we've talked about arithmetic operators, comparison operators, and assignment operators. The last thing we'll talk today is the logical operators. Logical operators always produce Boolean values, things that are either true or false. Now, I mentioned last week we have reserved words in Python, more reserved words. We knew that true and false are reserved words, and, or, and not are also reserved words. And they let you create Boolean values out of other Boolean values. Now, what I've shown here are what are called truth tables. And so what these do is they tell you if you have two things what the result of an and is, what the result of an or is, and what the result of a not is. So if you have a value that's true, call it x, and another value that's true, y, then x and y is true. That is the only time x and y is true. X or y is always true unless both values are false. So and is always false unless they're both true, or is always true unless they're both false. Not just flips the value to the other one. Okay? And so as we move into the second part of this lecture on conditionals, we're going to use these a lot. So I'm going to hold off working code until I start getting into the second half of the lecture in conditionals. But logical operators, what you need to know right now, they're sometimes called Boolean values because what they do is they always build you a Boolean value, true or false, out of either one or two other Boolean values. Now, so we have all these operators. As with anything else, when you learn your math, you have to decide what comes first. What do you do before other things? And this is a slide I stole from Dr. Johnson, who was the course coordinator when I started teaching in fall of 19. So thank you, Dr. Johnson, full credit for this. If you have a Python statement with various operators in it, the first thing Python will do, if there's no parentheses, is exponentiation. After the exponentiations are done, if there are no exponentiations, then it will do anything that looks like a multiplication and division. That's multiplication, floating point division, modulus, and integer division. And now, as with all your other math classes, if there's more than one in the statement, Python will go left to right. After having done the exponentiation and after having done all the multiplication, then you do all your addition and subtraction, and again, you go left to right. After you have done all of the arithmetic operators in order and all the arithmetic's done, then you move on to do comparisons. Now, a comparison, again, is always going to produce a Boolean value. Either something is true or false. Either something is less than or equal to something else or it's not. Something is equal to something else or it's not. So these are the comparison operators, and they are going to produce a Boolean, and they're done after all the arithmetic. And only then do you do the logical operators. You do not first, you do and second, and you do or last. If you have multiple nots, you do them left to right. If you have multiple ands, you do them left to right. But you do all your nots before your ands, before your ors. If this does not produce the result you want from your expression, then you can use parentheses. And as Dr. Johnson wrote, a meme a few years ago, honey badger don't care. Parentheses don't care. Parentheses always take precedence. Python will take anything inside parentheses and do it first. So let's take a few expressions here that are all built on the same characters, and let's evaluate each one. Okay, so the first thing we're going to do is we're going to take 6 times 5.0 okay, 6 times 5.0 plus 2 minus 5 divided by 5. Now, Python says there's no exponentiations. The first thing I do is all the addition and all the multiplication and all the division left to right. 6 times 5.0 is 30.0. 5 divided by 5 is 1.0. So now I have 30.0 plus 2 is 32.0, minus 1 is 31.0, and it works that way. But if that was not what I really wanted out of this arithmetic expression, I could start using parentheses. And I'll change it, even though it's all the same arithmetic operators and the same numbers, by changing operator precedence here, Python is going to go to the innermost parentheses first, and it's going to add these two first. So you're going to get 7.0. Now, inside these parentheses, it's going to go 6 times 7.0 minus 5. You do the 6.6 times 7.0 first. That's 42. Minus 5 is 37. 37 floating point divided by 5 should give you 7.4. Holy cow. I had 3 cups of coffee this morning. That's why I could still do this math in my head and get it right. Now, let's take another expression. 6 is less than 2 or 5 is greater than 1. 6 is less than 2. Remember, going back to our chart, okay, this chart right here, the less than is done before the or. The less than is done before the or. Okay, so this says 6 is less than 2. 6 is less than 2 is false. 5 is greater than 1. 5 is greater than 1 is certainly true. Okay, so now we have false or true. We can go back to the truth table here and see that false or true returns the value true. And so, yay verily, Python says this is true. So this is a Boolean expression, and it returns the value true. Now, let's talk about the next one. I want to explain how Python works, because it's kind of tricky. You don't have to pay too much attention. I just want to explain this to you in case you run into it. Here, I've used parentheses to change the order of operations. So the first thing that's going to happen is 2 or 5. Okay. Wait a minute. Why did this not give me an error? Why did this not give me an error when it evaluated 2 or 5? Okay. Because any number that is not 0 can be equivalent in Python to true. Okay, so let me see how I explain this. The number 0 is jumping ahead in the lecture. Okay, so the number 0 or the floating point 0.0 equate to false if you treat them as Boolean. Any other number equates to true. Now, this is a good part of the second half of this lecture, so I'm jumping ahead a little bit. We'll get into that. But for now, this is what the marker I want to put down. 0 or 0.0 equate to false if you treat them as Boolean. Any number equates to true. The empty string equates to false if you treat it as Boolean. Any other string equates to true. So let's go back and jump into the second half of the lecture. The point of this is just by inserting parentheses around here, I changed the value of this expression, which used to be true, to false, because I changed the order of the operators. Now let's get into the second half of the lecture, conditionals, and do some explaining why. Okay, so that was where we started on this. Now I want to get into program control flow. Everything we've done to date is sequential program execution. Through the course of the semester, we're going to learn 4 ways to control how a program executes. The first is what we've done so far, sequential. You write a statement and execute it. You write a statement and execute it. You write a statement and execute it. One after the other every time. No skips, no jumps, no backs, no nothing. But the second one is useful because sometimes we only want to take an action if something is true or something is false. And so we want to have what's called conditional control flow. Conditional control flow in a program says, if this is true or this is false, then do something. Otherwise, don't do anything. Do it only sometimes. So the term you need to remember is conditional control flow. Now, so conditional control flow says you have something that equates to true or false. It's a Boolean. And then the syntax is the statement if. Okay? So here is the simplest case. Y equals 5. If Y equals 5, print yes. And we see that yes got printed. Here is the syntax. Because there's a couple of things to pay attention to here. I've got them on the slide, but I want to talk about it. First of all, reserved word if, lowercase, and then a space, and now an expression that equates to a Boolean, something that has to evaluate to true or false. It has to eventually be true or false. And that's why Python put in the thing earlier where I said you can have things that are not 0. Okay. If Y is equal to 5, print yes. After the Boolean, there is a colon. The colon tells Python that this is the end of my Boolean expression. So take everything between the if and the colon and evaluate it and get a true or a false. Now, this can be as complex or as simple as you want it to, as long as it ultimately evaluates to a Boolean. If Y equals 5, or Y is not equal to 3, or Y is greater than 0, and Y is less than 1, colon, print yes. What's going to happen here is Python will go all along this chain and evaluate this entire thing, and as long as I get to a true or false, if this evaluates to true, it's going to execute this code. If this does not evaluate to true, it's going to skip it. It's just not going to execute it. So one of the things you need to know is this has to evaluate to a Boolean. It has to evaluate to true or false. The second thing is that after the Boolean, you terminate it with a colon. This colon has to be there to say that's the end of the Boolean expression, because Python does not limit you to 80 characters per line or wrap it on lines or anything else, right? Okay. If I wanted to say, pardon me just a second, I got a dog here. Okay, if I wanted to do something like this, if Y equals 5 and Y is less than 3, or y is greater than 2, colon, print yes. Okay. That colon is what's telling Python, stop evaluating this Boolean. Okay, so I don't want to do that, but we'll do that. But that colon's important. So 1, Boolean, 2, colon, 3, indentation. Python is a strange language in that white space is important. White space is tabs, spaces, new lines, things like that. In Python, after this colon, if this Boolean is true, Python will execute everything that's indented and stop when it's not indented. Okay, what do I mean? Let me give you just a little bit more involved example. Okay, let's set y equal to 5 again. If y is greater than or equal to 0, print y is positive, print y is non-negative, comma, and equal the hashtag, print that makes sense. Now I'm going to unindent and print we're done with the loop. Okay. Copy all of this. Okay, so before I execute this, we set y equal 5. If y is greater than or equal to 0, this is a Boolean. It's clearly going to be true. The colon tells it that's the end of the Boolean. Stop it. I've got 3 print statements, and then I unindented, and had another print statement. Now, what happens is this is obviously true. So it printed this statement. It printed this statement. It ended with a hashtag, so it didn't skip to a new line. It stopped right there and then printed this. Then it printed a new line. And then it got down and printed we're done with the loop. Okay. Question. Let's see. Couldn't flip you right. Oh, I'm sorry. I jumped ahead of you. I missed your question. Flip the order. Yeah. If you're talking about commutative operators, yeah, commutative means you can safely flip the order, and that's plus and times. But yeah, divide and minus, you can't flip the order. Okay, so sorry for missing that. Get it. Now what I'm going to do is take the same code that I did before, except I'm going to set y to -5. Now here's what's going to happen. Y is -5. This Boolean is going to be false. Because this Boolean is false, this is a conditional, everything that's indented is going to be skipped. These 3 print statements are not going to execute. But this is not indented. This statement is not part of the loop. This is not part of the if statement. This will always be executed. So when we run it, this is the only one that gets executed. So when you have a conditional, if the Boolean equates to true, everything that's indented is executed, and then we move on to the next thing that's not indented. If this is false, we skip everything that's indented. Anything indented is not executed, and we say we're done by unindenting, by moving back. So that's what I said That's what I meant when I said that Python is kind of a strange language. It's unlike a lot of others because this indentation is important. This indentation tells the program what to do when you are when your Boolean is true and when your Boolean is false. So going back to the slides, colon is critical. If Boolean expression colon is critical. If you leave it out, your program isn't going to work right because Python won't know where the Boolean ends. The second thing is Python is going to execute that Boolean expression and execute the code after the colon. That's indented only if that expression evaluates to true. If it evaluates to false, it won't do that. Now, that's in the simplest case where we only have one option. We're going to say something is either true or false. If it's true, do this. If it's false, we don't want anything to happen. If somebody printed in the wrong thing, print an error message. If somebody input the wrong value, print an error message. If this is what they typed, that's wrong. Here's an error message. If what they typed is correct, there's no need to print an error message. We're done, right? Move on with the program. That's the one option. That's an if, and then you don't have anything else. Now, sometimes when you're writing code, you have two options. You want to say if the user entered the right value, you say, thank you for entering the right value. And if the user entered the wrong value, you say, sorry, that's the wrong value. We do that with what's called an if-else statement. So there are two clauses in an if-else, if and else, and we'll talk about what that means in a second. And the last case is if you have more than two options. You can have as many as you want. You can have 3, you can have 33. It doesn't matter. If something is true, you take one action. If that's not true, but something else is true, you take a different action. Again, Python is shortening syntax. What you do is if this, else if, else if, else if, eventually, we shorten else if to elif. So this is the form we use when there are 3 options. Let's talk about some examples. I want a case where I just have one condition. If student major is equal to physics, colon, print. What a great choice. Print. You'll do well. Okay, now I need to assign something to student major to not get an error. Okay. Now I execute this. This was true, that's fine. If this was false, we do nothing. So let me go back to set your student major as music. Because why not? I've had a couple of great students who are music majors. It's an awesome major. Okay. So now let's execute that code. This is false. Student major is not in physics, it's music. Nothing happens. We don't print anything. So this is a one-choice thing. It's an if. You execute what's indented, and we're done. But maybe I want a second option. Okay? So let's make it a little bit simpler and have 2 conditions. Let's copy in our code from before. And now the syntax is we unindent, we have to start in the same column as the if, and we type else, colon. Now, else it's just else colon because there's nothing else we're going to do. Anything other than physics, we're going to print. That's not a bad choice. Now let's execute this code. Okay, now remember, student major is comp sci right now. So what should happen is this Boolean is evaluated, and it's going to be false. So we will skip everything that's indented. We'll come to the else, and we will execute whatever's indented down here. There we go. Okay, so an if-else, the syntax is, if this Boolean equates to true, you do whatever's indented up here. Otherwise, this Boolean must be false. You come down here, and you execute whatever's indented down here. Now, again, the indentation is important because if we put something that's unindented, that comes after everything. Okay. So what do I mean? Okay, now your major is still comp sci. So we'll execute this. And we noticed we printed the indented thing because it's part of the loop in the else. And then this is outside the loop. So we always go outside the loop at the end and print that. Okay, let's go back and change student major equals physics. And hopefully I haven't typed anything wrong. And now what's going to happen is this Boolean was true. Okay, this Boolean was true. So we executed what was in the loop. We skipped this. And now we went to the first thing that's unindented, and that always gets executed. Okay, so that's what's happening here. That's when there are two choices. Now, what if there are more than two options? What if there's a third thing? And the example I give in the slides is, as you're all aware, before you're 18 years old, there's a lot of stuff you can't do. Between the time you're 18 and the time you're 21, you could do some things like vote in an election, but you can't do other things like drink alcohol, at least not legal. Okay. So what I've got is a case that looks at your age and says, if you're 18, if you're below 18, you can't do anything. If you're 18 to 21, you could do this. And if you're over 21. Okay, so let's kind of go with an example like that. I think this is going to be a little different in the slides, but you'll get the idea. This is what you would use if there were 3 or more cases to cover. Age equals, and we're going to start by just saying arbitrarily 16. Our first condition is if your age is less than 18, colon, print, sorry, you're a minor, print, there are lots of things you can't do. Okay, so that's if you're under 18. Now, what if you're 18 or 19? You certainly vote in the election, and I hope you did. But you can't drink. So we want to cover that case. Remember, I said it's kind of like an else if, but syntactically with Python, they made it a little easier. You don't have to type else if. You only have to type 4 characters, elif. Now, when you give elif, else if, you need another Boolean. And here's where you have to start thinking about how you're going to construct your Booleans. I could say age is greater than or equal to 18 and age is less than 21, colon. Here we have another colon. This is perfectly valid coding. It would work. But let's think about this. If age had been less than 18, we would have executed this code. We would have ignored everything else. So I know that I don't have to include this. Why do I know I don't have to include this? Because age already has to be at least 18. If age is not at least 18, I execute this part of the if statement, that condition. I never get here, so I don't need this. Now, we won't penalize you for putting it in. We won't penalize you for putting it in, but you have to start thinking about this. You have to start figuring out the right way to do things. You don't need it. So we're going to leave it out. So now, if your age is 18, 19, or 20, now print you can't vote, or you can vote, and we hope you did. Print, but you still don't have all privileges. Okay? That's the end of that. Now, in this case, I'm just going to have third case. There's no set of rules that you have to be at least 25. I mean, I could say, you know, if you to run for Congress, you have to be at least 25. So I could say, if age is less than 25, you can't run. You still can't run for Congress. But whatever, we're going to skip it, and now we're just going to say else. Now, just like in the two cases, else means anything else, any other thing. I don't have to have a Boolean because it's anything else. Now, that's the same as saying you're 21 or older, print, you are now an adult. Okay? Before I use this code, though, I'm not going to do age equals 16. I'm going to get the age. I'm going to ask the user. I'm going to say age equals int of input, enter your age in years. Okay. Now we'll execute it. Makes it easier to run it this time. Okay. So we execute it. The first thing is age equals, enter your age in years. Remember the input. This becomes key in homework. In homework 1, the input statement always reads things in as a string. So that's why we have to say up here, cast it to an integer. Take your age in years, enter it. It's going to come in as a string, and I'm going to change it to an integer. So let's say I'm 35. Now we can walk through, is age less than 18? No, that's false. Is age less than 21? No, that's false. So we'll go to the else. You're now an adult. Now let's run the same code. Now I'll say I'm 16. Sorry, you're a minor. Let's run the same code. Now I'm 20. You could vote, and we hope you did. You still don't have all your privileges. You can't drink. Okay? There's certain other things you can't do. So this is a conditional expression, an if, elif, else, so that you've got all three different things that you're talking about. And you could have as many elifs as you want. So going back to the slides, the simplest, the if statement, you only have one thing. If this is true, do something. If it's not true, nothing happens. Boolean, colon, indent. Two cases, if and else. Okay? If Boolean is true, do this. Else, do that. Colon goes after the else. These are fairly common errors. Don't worry. You'll have them. You'll fix them. It's easy. You'll debug. Okay? You'll have to fix your code as you go through. Test it every few lines. The input always returns a string. In this case, in this example on the slides, we're comparing strings to strings, so that's valid. Okay? And indent the stuff that's there. Here's a note on the slide about indentation. Anything that's indented is going to be executed when this Boolean's true, and then we skip down to the thing that's not indented. Okay. Here in this example, I should have made it clearer, but over here, this is not indented. It's the same line, same column as the if. That's indented, so I tried to make that a little bit clearer. Okay. So remember, what gets executed is what's indented, and indentation is key. Now, if you'd like to start a war that's almost religious, the question is, do you indent in Python with tabs or spaces? If you watched the show Silicon Valley a few years ago, there was a whole episode where there was almost a fight between two of the major characters over whether you indent with spaces or tabs. It doesn't matter. I use tabs. PyCharm by default uses tabs. You can use spaces. If you use spaces, you only have to indent one space. Okay? You only have to indent one space. That can get hard to read, and if you're debugging your code, if you're finding your errors, if you're trying to find out why something is indented or not, if you've only indented one space, that's going to be difficult. So if you want to indent with spaces, I would recommend you indent with about 4 or 5. I use tabs. But trust me, I can find tab is better. There we go. Yeah, like I said, I will find you people who say it's all spaces. It's almost funny the things people will fight for. But the bottom line is either works. Tabs or spaces are both valid. PyCharm uses tabs by default. If you are going to use spaces, you only need one. A note about if you have the if-else form. If you have the if-else form, there must always be at least one line of code under the if statement. You cannot say something like this. If x, let's see, this is going to be a x equals 5. If x not equal to 7, else print not allowed. And let's make PyCharm give me the error message. Yes. This error is because I had an if statement with no code before else. So what that slide is telling you is if you have an if else, then there has to be at least one line of code under if. There has to be at least one line of code under if. If you have an if and then no code and just straight to an else, that's a syntax error. The reason being, there was a better way to write it. Python knows there was a better way to write it, and so it's stopping you. So if you have an if and you have an else, you have to have one line of code under the if. If you have the else, there has to be at least one line of code under the else. Remember, if you don't have any code under the else, just leave it off. If, Boolean, do something, done, no else. If you put the else colon there, there has to be a line of code indented, or else it's not valid. Okay. And 3 or more cases, the elif. The example here is I turned it into an int. This is pretty much the same as the example I worked through in PyCharm. It's a little bit different, just to show you the simple thing. If, elif, else. Again, syntactically, if, Boolean, colon, at least one line of code, more is okay, but indented. Unindent, elif, Boolean, colon, indented at least one line of code. If you don't have a line of code there, don't put the elif. Okay, you have to think about how you want to write these. Else, at least one line of code. If you have an elif, you must have an else. Okay? If you're writing an if, elif, and you can't figure out that there's no else, you don't need the elif. Just use an if else. You can always figure out how to write this. Okay? So those are the 3 cases of conditionals. Now with that, since I've got just a few minutes, I want to talk briefly about homework 1. So let's go to that assignment. I made a note in Discord about why we have these sections, allowed and unallowed. people, and I apologize, this is computer science, not programming, and people who have programmed for years get frustrated over this because they know a way to solve a problem and we tell them you can't use it. We want you to learn all the tools in the toolbox. We want you to master the elements of Python so you can use whatever tool is appropriate for the job. There's an old joke about if all you have is a hammer, everything looks like a nail. This is a screwdriver. This is a screw that takes a Phillips screwdriver. Well, I don't have a Phillips screwdriver. I've got a hammer, so I'm going to bang this sucker in. You might or might not be able to make it work. If you do, it ain't coming out. You've messed up. Okay. So we want you to get out of the habit of just having one tool that you use to solve all programming problems. We want you to get in the habit of using whatever Python tool is best for the job. And part of that is knowing which tool is best for the job. So we tell you for homework 1, this is allowed, and the others are not. And then as we go through the semester, you change. Declaring and assigning variables, you know how to do that. Casting using the int of the input, you know how to do that, and that's important. The arithmetic operators, all the logical operators, all the assignment operators, everything I've just shown you about, that is legal. Print, you definitely have to use the print statement. You can use F strings if you want. You don't have to use F strings to do this. Like I said last time, it's not mandatory, but you can if you think it makes it easier. The comment here, we don't care how you format the strings in Python, just get them to print. That, formatting output is not a major part of computer science. It's cool coding, but it's not. You won't need these things, but if you somehow figure out you stumble into them, they're okay. Input, again, using what's provided. You get starter code as part of this. You can use that. You can't use any of these things. Again, this is stuff, if you've learned programming before, please don't do this. If you go to chegg.com or some other site on the internet and you download a solution to this problem, you will find all kinds of these illegal, forbidden methods in there. Guess what? That's one of the ways we know that you cheated. It's one of the ways we know you downloaded code from the internet because you used a bunch of stuff that we prohibited from using. Okay, this is stuff that's really overkill. You don't need that to solve this problem. Okay, all you're doing in problem 1 is asking the user for adjective, noun, event noun, and verb. These are 4 input statements. You input 4 strings. Once you input the 4 strings, it's a matter of printing out strings. Print, then print another thing. You could use F strings if you want to do this output, but you could do it with just plain print statements, and you can make it look real nice. All part 1 is 4 input statements, get the values, and then do some string printing. That's really to get you comfortable with making this work. Okay. Problem 2 is the same thing. Ask for a game, which is a string. Ask for a number of players and change that to an int. That's what we did today with the input. We put int of input that changes into an int. Ask for a number of minutes, cast to a float, display a string, and do some division. You know how to division. You know how to divide floating point division. Okay. And you'll notice here it's floating point because ours is float, not int. Don't worry, if you want to use F strings and cut the number of decimal places, that's certainly fine. But again, you don't have to. You don't lose any points if you don't. Okay. Similar to 3. 4 looks scary because it's the Drake equation. It's got a lot of strange symbols in it if you're not familiar with physics or astronomy, but it's really the same thing you've all been doing. Ask for where you are, ask for a number, ask for a height, calculate using the formula, and print it out, and you're done. So homework 1 is really straightforward. Just, it's just asking and printing. Okay. Does the last option always have to be else? The answer to that question is yes. If you have an if, you have to have an else. Now, remember, you can have an if with no else. You can just have if this, nothing. You don't have to have an else. You can just have an if. But if you have anything, if you have elifs, you always have to end with an else. So if you have anything after the if, the else has to be last. Okay, so hopefully that answers that question. All right. I am out of time. The lecture notes will go up there. Thanks to Kevin, one of the TAs. He did point out, which I did not realize, that we who have umbc.edu email addresses can get the professional version of PyCharm free. You can get a 1-year license for free by registering rather than using the free community edition. Now, again, this is all optional. You don't have to use PyCharm at all. If you have the professional edition of PyCharm, you can program it, you can set it up to sync directly with gl.umbc.edu so that when you create your Python file on your laptop, it is automatically loaded onto GL in the right place for you. And we'll talk about that. If I get a chance, I'll post a separate video on the YouTube channel telling you how to do that. If you have questions, we can work through it. It's the documentation page is fairly straightforward, but I'll try to get a video in the next day or two. If you want to do that, that is completely optional. As I said, I did not realize you now can get things free. You can now get the professional version free. You don't have to pay for it. It's up to you. It's an option, but it's an option that's out there. And with that, I'll quit recording, but I will be here for a while if anybody has any other questions.